Hello everyone and welcome back to my channel. Um, so as you all know, I finally got this thing working. So now what I'm doing is just all the compensation and stuff like that. However, I noticed something. The left channel or the master output, it goes up to 31.5 volts. I thought it went up to 30.5. Could be wrong. I'm going to have to go back over footage. But this happened after I was doing some tests on it, and to be honest, I accidentally shorted the slave output whilst it was in auto tracking mode, and I only noticed the master channel going all the way up to 31.5 volts after that. So I thought, have I damaged something? I don't know. So I replaced this op amp first because this is the most susceptible one. Made no difference. Changed this one, made no difference. Then I started measuring because I thought, okay, maybe the problem was already there. So then I started measuring the resistor values, the gain setting resistor and the two voltage divider resistors that go to the non-inverting input of the op amp. And in circuit they seemed slightly off, like not high tolerance, So I took them out and they were literally measuring better than my own high tolerance 1% resistors. And these aren't even 1% resistors. So either they were just damn good or someone hand matched them. Anyways, I put them back in and I realized that this tantalum here has leakage on it because when that resistor is in parallel with it, it measures at about 1.92k even after the cap charges up, whereas the other one actually comes up to 2.2k after the cap's charged. So I'm going to change those two tantalums, put it in again, and I've got a funny feeling that's why the voltage is too high on one channel, because there's a little bit of leakage through one of the resistors on the divider. Well, not through the resistor, through the tantalum cap, but yeah, so I'm going to have a look at that, and then if that doesn't fix it, I'm going to change this op amp. The reason this is the last one I've left to change is because it's the current measuring op amp, but because I shorted it, I could have induced a spike across the current shunt resistor. So it's possible, because these are JFET input op amps, so I could have put a spike into that and destroyed that too. I just thought I'd look at the voltage ones first. Something else we've got to do on top of compensation is I want to add clamping to all the inputs, because these things are JFET input op amps. They're sensitive to spikes and stuff like that. It's a power supply. The feedback lines basically go back to resistive dividers and to the inputs of the op amp. The negative or ground terminal, whatever you want to call it, well, not ground, negative, literally goes straight back to one of the inputs on some of the op amps. So I definitely want to add clamping on them. So when I use inductive loads, short the outputs by accident, all that sort of stuff, I don't damage the op amps and have to keep replacing op amps all the time. But with that being said, I've just put these resistors back in that I marked and took out hastily, thinking that it would be them after changing the two op amps that are responsible for the voltage, and it made no difference. So I'm now going to change these tantalums and try it, because I'm pretty sure this has got leakage on it, which would totally cause this problem. If that doesn't fix the problem, then I'm going to change that op amp. If that doesn't fix the problem, then it must be something that just comes down to the tolerance of one of the resistors in the circuit, and that's something else I'm going to get to. Now, I'm not aiming for the most crazy accuracy in the world here. We only got two LA72s and 1 ohm shunt resistors, for example, But at the same time, the person who replaced the resistors on the current op amps inputs, they're bloody 10% resistors. Everything in here is a 1% resistor or a 2% resistor. That's going to throw the current measurement off quite a bit. And I measured them. One's like 4.8 something K, the other one's 4.696 or something. Some of them are close to 4.7. So we're going to change them to 1% metal film precision V-shaped resistors. They're not going to need to be the size they are. I think they just used those resistors. They literally just go to the inverting and non-inverting input of the op amp and then go back to the current shunt. There's no current flowing through them. I could put 1/8 watt resistors in there that are that small. I'm going to be using 1/2 watt metal film resistors that look like this. So we're going to do that. But right now I got to sort this problem out because I'm just really fussy. I want everything accurate. Other thing I want to point out, I worked out what these pots do. They're to calibrate the panel meters. So obviously you got the zero adjust on the panel meter. So when it's turned off, I set the zero adjust so the panel meters are bang on zero. This grey pot sets how high the meter can go when it's like, I set it to 30 volts and then adjusted it until the scale's on 30, and now the scale's perfectly accurate. The other one, you do the same thing for the current. You put 1 amp load on it and adjust it until the meter displays exactly 1 amp. I can go over that and show you guys if you want, but I mean, that's all there is to it really. I mean, you've just got the little screw underneath the panel meter, just there's a little screw here. And you just turn that when the supply's off to get this on zero, and then set it to a known voltage and adjust the grey one until the meter displays the correct voltage, and the same with the yellow one for the current. So I don't think you guys want me to waste time doing that, but if you do, leave it in the comments and I'll do a video on that, because that is the calibration of it. Because of the way the unit works, it's actually quite accurate, because it basically it's the same. It operates on a similar principle to the way my supply works. It compares the voltage against a reference, but you adjust the reference voltage to set the output voltage, and the panel meter monitors the output voltage. So when there's no load on it, the panel meter is actually monitoring the set voltage or the reference. And then when you put a load on it, the panel meter then displays the voltage drop at the terminals, obviously not at your load on the other end of the wire. It's not 4-wire. It shows the voltage drop under load. So it's actually really accurate. Same thing for the current. So the way that system's implemented is pretty smart for back in the day anyway. You can get good accuracy just out of using one panel meter. Anyways, before I get carried away talking, I'm going to leave this video here because I splice all my videos together. I'm going to go change these two tantalums. Yeah, see if I still got this 31.5 volts on the left side. If I do, I'm going to swap that op amp. I do realize I could also go through my videos and have a look, but I'm pretty sure it's supposed to be 30.5. I clearly remember it being 30.5. Like my memory is clear on it that I don't want to go look at a video, because I'm damn sure it was 30.5. Whether that changed when I shorted the output on the slave when it was in dual tracking mode, or that just changed over the course of me rebuilding the thing, I don't know, but I just want to hunt it down. I've got a feeling, like I said, I just found it, that cap's got leakage, so I'll go sort that out. I wouldn't be surprised if they both got a little bit of leakage. You know, it's a 30 volt supply. I wouldn't be surprised if I change them both and it ends up being 30. That was leaking 1/2 volt. The amount of resistance to make it go over 1/2 volt, and that 1.5 volt worth of resistance of leakage. But yeah, sorry, I'm wafting on. I'm just trying to explain more thoroughly to everyone so no one's confused over anything that I'm doing, really. And so people can learn and understand how things work and all that sort of stuff. What else? I swear there was something else I was going to do. Oh, the OR gate diodes. I will end up replacing them with like UF400 or whatever I've got. Maybe Schottkys or something better. I'm not too sure. I haven't put too much consideration into it. Once again, it's only TL072 op amps. It's 1 ohm current shunt. It's not, it's only TL431A reference based. It's not, the most accurate thing on it. The rails that run the op amps are derived from plus minus 10 volt Zener rails, like 20 volt differential, it's not the most accurate thing in the world, but it's still is quite accurate, to be honest. And I do want good feedback response on it. So I don't know what the characteristics of those diodes are. They could have a huge junction capacitance and be quite slow. I don't know. You know what I mean? In most of the operation, they're forward biased and they're on anyway, so that doesn't really come into play. But when it's going in and out of in between constant current and constant voltage mode on switchover, well then if they have huge capacitances, that will add a more overshoot or undershoot or time in that switching period, if that makes sense. So yeah, so anyway, I go on way too much, and yes, I am one of those people that enjoys sitting there and making everything better and perfecting stuff, but like I said, I'm not going to go too crazy on it, I'm not going to put AT or 431Bs in there. I'm not going to put proper make a 1 ohm current shunt up out of Constantine wire, although I've got it. Nah, it's not worth it, but I do want to make it, as fast as I can make it and as quiet as I can make it, basically speaking. Actually, one thing I am going to do, I did load it at 1 amp, and these resistors get warm. Not hot like the 3 watt ones did when I loaded it, but I'm going to change them to 10 watt ones. I bought them the other day just in case, because obviously the less the resistor heats up and the longer it takes to heat up too, the more time and accuracy you've got on your constant current setting. So obviously using a nice current shunt would be the best way to go, but you need a big resistance for the input offset voltage on these op amps. And yeah, so I'm just going to put the 10 watt resistors in there and just stand them up a little bit off the board or whatever. I'll work out how to fit them, but that's what we're going to do. So I'll go do these caps now, I'll come back, and then we'll start with all the resistors that are the wrong precision and everything I've just mentioned. See you soon. Alright, so I changed the Zeners and sorry, not the Zeners. What am I saying? Tantalums. The tantalums. I changed the tantalums, and still 31.5 volts on that side. Yeah. What? Oh, I know why that's like that. When I put the gain setting resistors back in, damn it, I put the wrong one. Obviously, the people that built this, they chose the resistors out of a pile by hand to set the gain exactly right. I know exactly what that is. I got to swap the gain set resistors around. That's okay. Let me just have a look at this. You know what? I wouldn't be half surprised if this voltage pot, because this is a bit dodgy. I was going to change it anyway. See, the one that I've changed, now I can turn it up and literally set it. I'll prove this just so people know I'm not talking smack. I'll have to come down in voltage because this is only on a 6,000 count meter. I could grab the other meter, I guess, but anyway. So with the pot I put in there, if I set it on like a certain millivolt, honestly, it's because of the way I'm standing. I was having a play around with it before. I mean, obviously, you're not going to use a 10-turn pot and a panel meter to set 1 millivolt. But the point I was getting at is, see what I'm saying? You can turn it by really small increments if you need to. The other pot, it's, you know, even up at, let's go down. It's really loose, is the point I'm getting at. So it kind of, I guess it doesn't really look any different on camera, but you guys don't have the feedback I have in my hand. Like, how do I explain it? When I set it somewhere, I just let go of the knob and it jumps up like 15 millivolts, if that makes sense. Like, it's all loose and old and worn out. I'm curious if the value of that pot's gone up in resistance. Because if the thing's not 10K anymore, that's going to mean that, what can we call it? That'll explain why it's at 31.5 volts. Just like the other pot being 20K made it try and put out close to 60. So I'm just having a look at this other side. Yeah, 29.43. Alright, I've got to swap the gain set resistors around. Anyways, I'm going to take this pot, or just desolder one wire off this pot quickly. And let's just do a quick measurement, eh? Let's see what we got from end to end. Very curious. I wouldn't be surprised. Yeah, even the tags are loose where they come out the back, which is never a good sign on this style of pot. Less than 10K. Okay, so it's not the pot. Very interesting. Less than 10K. What have we got in between what's being used when it's turned up to max? I'm just curious. I wasn't reading from end to end. So it's just over 10. So the thing is, because this is such a high precision circuit, it's in the it's not the feedback. Sorry, it goes to the inputs. A resistive divider that divides down voltage to the inputs of an op amp, right? So it's got to be precise. I just want to see if this one's closer. I'm going to swap it anyway because it's nice and tight. It's not all loose and sloppy, but just my own curiosity. What? Must have had a bit of oil or something there. It's brand new, that's why I was like, what? Probably a little bit of assembly lube or something inside it, or a speck of dust. So it's just under 10K. I'm going to put that in. I reckon that's what it is. The pot, over all the years of it getting used and, you know, possibly high voltages put across it when the thing's been broken, because these are wire wound, but mainly from the wiper wiping over the wire, it's probably rubbed the wire down and made it thinner over the years, effectively making the resistance go up. and whatever pot they put, like, or the pot, when they put that pot in there when it was brand new and they set the gain, well, not the gain so much, but the voltage, the resistors in the voltage divider that are in series with this, they would have specifically chosen them for whatever value the original pot was when it was fully open. That's just how this circuit works. So that answers that question. I'll put that in, we'll see what the voltage is. I'll be back. Well, I changed the pot, 31 volts now. That's not good. That pot has got something wrong with it. Let's give it a little bit of a wiggle, wiggle, wiggle. It is a brand new pot. I'm just going to turn it up and down a few times. But that's not supposed to happen. The wiper's not supposed to lose contact with, what do you call it, the wire wound coil. That is not right. Which is what's happening there when it's going open. Okay, I think there was just a bit of dirt in there. Seems rock solid now. I'll definitely be keeping my eye on that. Last thing you want is a circuit hooked up and it all of a sudden jumps up to 55 or 54 volts. Could you imagine? Let's just see what's down the other end. Yes, my cat's destroying the chair. You've got to be kidding me. What the? This pot's completely gone. You're seeing this? Wow. Unless, you know how I was saying I'm still going to change another op amp because I think one of the op amps is buggered in there. There is a possibility and it's just buggered itself even more. Wow, that's odd. The other side's still perfectly exactly where it was. Just want to see if the constant current amplifier is working. It is. Oh, I think the constant current amplifier was oscillating. Yeah. Okay. That was the constant current amplifier op amp going into oscillation. That makes perfect sense. Okay, so it's amazing. That's definitely, you know what's interesting? That's the op amp that I was just about to change. Like I changed two op amps, which did nothing. Changed the tantalum cap, which did nothing, or two tantalum caps. Moved resistors around, changed the pot, and this side still has a higher voltage. And I was thinking the whole time, I was saying to myself, I wonder if the other op amp that does the current's doing it, because they go to an OR gate So it is possible for the other op amp to have control over it, especially if it's an oscillation. Yeah, I'm going to say that that's what's wrong. I just want to see with the current on full. Yeah, but see if I play with the current knob. Go turn the current down. Oh, now you don't want to do it. Someone at my door and I'm working on stuff. I'll be back. Alright, so I've been playing around with this for a bit, trying to work out if that's an op amp going into oscillation or have I got a dodgy pot, and I can't get it to happen anymore. So, given that I literally have not seen that happen on this before, and I just put that pot in, I've got a strange feeling it was the pot. I think these might be knockoff V-shaped pots. I actually bought them off of eBay a while ago, and I always wondered if they were like genuine or not, you know. But yeah, I'm kind of curious about that. Anyway, what was I going to say? Sorry, I got that much on my mind. I can't remember what I was going to say now. Oh yeah, I'm going to pull it apart. I'm going to just disconnect the current op amp's output from the OR gate and turn it back on and see if the voltage is still at 31 volts before I go and change the whole op amp, obviously, because you know that would kind of be silly. Although maybe no, what am I saying? The voltage going too high. The op amps can only sink current. The diodes point into them. Actually, it could, yeah. That won't be a very good test, because if the op amp's supposed to be pulling it down very slightly, so it's always kept within a constant current limit, maximum of 1 amp, disconnecting it's not going to tell me. I got a funny feeling it is. I'm just going to go change that op amp. Yeah, because disconnecting it, I don't think it's going to be a very decisive test. So, I'll be back soon. Alright, so I got a couple things to let you all know. The leaky Zener, why do I keep saying Zener? Tantalum capacitor, it was leaky. I tested out a circuit. The resistance only climbs to a few kilo ohms and then stops climbing. When I say a few kilo ohms, I actually mean quite, it's about 17 kilo ohms or something like that. 17.5 kilo ohms it climbs up to before it stops, and the other one just keeps going. Anyways, so obviously it was leaky, but it's not on the feedback. What it was the what do you call it? The bulk reservoir for the reference voltage. So, seeing as it was the bulk reservoir for the reference voltage, you can guess what I did when I replaced it. I didn't put a 4.7 microfarad one in there. I put a 10. I think, or was it 22? Sorry, let me just go have a look, because I might have been out of 10s. Yeah, 22 microfarad I put in there. Oh no. Wait a minute, I think I got the wrong Zeners in the wrong drawer. Oh, goodness. I'm going to have to take them back out. I put 16 volt Zeners in there, they were 35 volt Zeners. if you come to think about it, I think they just used that because that's what they had, because there's no way that part of the circuit has that voltage going through it. I'm just going to make sure that there isn't output voltage like going back in a feedback loop through that. And if it really is just a low voltage, then I'll leave the 16 volts. Oh my god. Tantalum's in there. Otherwise I'll change it. So anyway, might screw up. So I changed 2 of the resistors on the inputs to those op amps and the 2 gain setting resistors, and now the second side that was only doing 29.5 goes up to 30.25. Very happy. The other side, well, we still got to fix that, but I was having to think about it and it dawned on me, I know what it is. It is the other op amp. If you think about it, and when I say the other op amp, I mean the op amp that sets the, that's just a little bit lower because I swapped the gain setting resistor values around. But if you think about it, the way the constant current function works, even when that knob's turned up all the way, the current op amp still is actually pulling that OR gate down a bit, right? Because if it wasn't, the power supply would be able to spit out more than 1 amp. So what I think's happened is I've buggered that current monitoring op amp, and it's not pulling the OR gate down completely to where it's supposed to pull it down to, like the correct level, and that's why the voltage is coming up a little bit too much. So I'm going to change that op amp, and I can almost guarantee that that's going to solve that problem. And I guess then we're finally on to what I said before about compensation and all that. So I guess this video is probably a bit of a waste of time for most people to watch, but I just wanted to be honest and show all my screw ups and what I'm doing, really. So there you go. I'm going to go change this op amp now. I'll come back and we'll make sure that they're both hitting around 30 point something volts. As long as it's around, 30 to 30.5, I'm happy. That's in the ballpark where it's supposed to go up to. There's no like high accuracy set limit as to like exactly how high it can go. I mean, you could put a trimmer resistor in there on the gain setting pot. On the gain setting resistor on the op amp that compares the other op amps monitored, or should I say sampled, output voltage against the reference on the second op amp. I could put a trimmer pot on that and fine tune it, and they'd both then go from exactly 0 to exactly 30, but I'm not worried about that. As long as I can get them to both turn down to exactly 0 in current and amps, I'm happy. If it goes up to 30.25 or 30.5, that doesn't matter, as long as it's, the 31.5, that tells me that something's wrong, because I went over my video footage and I had a look, and it was actually 30.5. And as you can see, the other channel basically is always around that too. So it's obvious that something changed, and I'm pretty sure it changed after I shorted the second output when it was in auto tracking mode. So I'd say the induction of all of the wiring loom and the power supply and the 1 ohm current sense resistor, all that inductance would have formed such a voltage spike when I released the shorts. A 1 ohm resistor with all that current going through it you'd still get quite a big voltage spike off of that, enough to damage JFET inputs on an op amp. So I'm pretty sure that's I'm sure that's what is going on. So I'm going to change that op amp now, and then I'll just come back just to confirm and show you guys that the panel meters are calibrated in volts and amps and that the whole thing's functioning perfectly. Oh, and one other thing I've got to tell you guys. We're not going to have to do too much compensation. I'm going to get the scope and have a look at everything. But the slave channel has no oscillation at all. The master channel is the only one that's got oscillation. And as I've just realized, we've got a funny op amp. So I got a funny feeling that we're going to be doing less compensation than what we originally thought we were going to be. And I'll just, before I stop recording, to go and do this, change this op amp, I just want to point one other thing out. Here on the current monitoring op amps, that capacitor there is across the inverting and non-inverting inputs. So that's a form of compensation. Now, that is a old school way of doing it. Nowadays we would put a smaller value cap here in between the pins, and across the current shunt we'd put a resistor going, like a 10 ohm resistor going into, say, a 100 nanofarad cap going into another 10 ohm resistor, and we'd place that snubber network across the current shunt. And that means that we can get away with a smaller value here, which effectively allows the op amp to work faster. So anyway, that'll all get covered in the next video, like I said, because that's going to be a long video. I'm going to have a lot of explaining and stuff to go over. So that'll be a video of its own. So I'll change, which one is it? This op amp now, and I'll be back in a minute. Alright, so I'm going to have to hold the phone to show you guys this, but the constant current problem, it is actually the pot. The constant current pot. When I traced everything back out, it seemed like it was this. Anyway, look, I'm just going to short the top half of the pot, which would effectively do that, and sure enough, it does. See? So the pot's just not going down to 0 ohms anymore. And I put the multimeter on it, and sure enough, that pot, when I wind it down in between the center wiper and the outer position, it only goes down to like 1.2 ohms, 0.9 at the most if you ram it. The other one goes down all the way. So the pot's buggered. That's all it, see. Oh, no. The other thing, excuse me, I noticed was, can you stop playing? If you try and turn it down as much as you can, turn it off, really hold it hard, you see how the voltage is rising slowly. As soon as I let it go, it goes up. So yeah, it's just a pot. That's literally all it is. Yeah, so that extra bit of voltage there, that's just offset. I've just got to trim the gain on one of the op amps. Only because I'm a perfectionist. I could leave it there. It doesn't matter. There's no problem with it. It just means that one channel goes up to 30 volts and the other one goes up to 31 volts. But I'll probably trim it out. Who knows? I might leave it. But the main point is, at the moment, I've got to get, well, obviously I'm going to change both of them like I did the voltage pots. So I'm going to have to get two 500 ohm multi-turn pots to fix that problem. I will have a quick look and see. No, actually, I'm just looking from here and I can see it's all plastic welded together. It's a different type of pot to the other pot, so there's nothing I'm going to be able to do in regards to that. But yeah, I mean, it kind of sucks, but it is what it is. I'm just going to have to wait until I get the right pot and just not use that channel, at least for now, because the thing is, the constant current circuit pots have got 3 wires going to them, and the way it's hooked up, to cut a long story short, if the wiper comes off of one position, it can cause rapid fluctuations in output voltage and current. And because the pot's that dodgy, I mean, it's that loose literally that you can I don't know why this one that I just put in is doing that, because I just bought it, whatever. But yeah, you can hear the current pots, they're really bad. And especially that one. So, what else? I can't remember if I mentioned this or not, but I ended up checking those tantalums that I put in there, the 16 volt tantalums, under full load, no load, full voltage, no voltage, no matter what condition the supplies are under, dual tracking, single. They only have 10 volts on them, so the 16 volts are going to be fine. I changed out that op amp that I thought might have been the cause of the extra volt, because I thought the constant current circuitry wasn't working, but again, turned out to be the pot. If I change that pot and the extra volts there, it just means, like I said, that the offset, not the offset, the, what do you call it? The gain on the voltage air amplifier op amp just needs to be tweaked ever so slightly. That's literally all that is. So, basically now I've got to work out what I'm going to do. I got to actually, what I can do quickly is I'm going to reverse engineer the constant current circuitry, because I don't know that, you know, it has to have 500 ohm pots in there. I just have to have a look at how it's all done. The lowest 10 turn pot I've got is 5 kilo ohms. I do know that. I'm pretty sure it is anyway. You know, there's a good chance I could convert it to a 5k pot. I don't know what it's doing. I mean, obviously it's only setting a reference point for an op amp, so it's not like a 5k pot couldn't supply enough current for a reference. So it's going to come down to other resistors that are in the divider network and their values and the current that's pumping through them as to what I could do with the pot. But the thing is, if it's, look, I'll trace the circuitry out. Basically, if it's, you know, like just change the value of 2 resistors on each side and then I can put 2 5k pots in, I'll do that. But if it's like going to be a lot more hacking circuitry, like, you know, cutting traces, changing 10 components on each channel, all that sort of jazz, I've already done enough of that. I'm not going to do that. I'll just order the pots, you know. I've pretty much made what I wanted to make better. The driver transistors have got, what do you call it, better smoothing on them. All the main filter caps are better. You know, there's references in there. There's better op amps in there. You know, it's, yeah, I'm pretty happy. I've got knocked off a whole lot of inductance out of a lot of different areas, feedback loops, current shunts, power supply parts, just, you know. Yeah, so with that being said, I'm going to go off now, have a look, see if I can do something about changing the pots to 5k pots, or is that going to be too much of a F around and I need to get 500 ohm pots? And then once I've solved that question / problem, we'll look at compensating it, or what we have to do to make sure it's stable under all different conditions, you know. And also one thing I forgot to mention, in playing around with stuff, the calibration for the current on the panel meters is ever so slightly off again. So because I never did the calibration on the panel meters on video, when I go to redo the current calibration, I'll do that on video this time, so everyone gets to see it. Same procedure as the voltage for the current, except for obviously you've got to put a load on it because the voltage is there. If there's no short or no load, doesn't matter, you know. Current's only flowing when the circuit's complete, so that condition's different. But other than that, you turn it up to full and adjust the pot until the panel meter reads what full is, what value full is. Anyway, I don't want to go on talking. Just wanted to show you guys that because that's really good news, because in the last little bit of this video I was thinking that there's still problems, and there isn't. It's just pots. So we're actually up to what compensation, putting high tolerance resistors in for the gain setting area, where I'm talking about on the lower board on the input buffers, where someone's changed resistors and they clearly used to have resistors with a brown stripe at the end, which is 1%, and they've put ones with gold stripes in on the end, which are 10%. So it might be 5%. No, I think they're 10%. Could be 5. I can't remember. But either way, they're an order of magnitude off. So I'll be doing something about that. Yeah, I might throw a couple more little treats in there for it. Who knows? But yeah, I'm gonna go trace out this circuitry for this pot. See if, like I said already, see what I can do with it. And I don't know what to say. The thing is, this could go two ways. I could have to wait for a week or two for pots to arrive if I've got to order them, or I might be able to change something and get it up and running tonight. So I don't know if we're going to be continuing on with this video series, like as in tomorrow and the next day and day after, or we're going to be working on something else and then coming back to this in a week or two. Who knows? I just got to work out what to do with the pots, because I'm going to do both of them, obviously. And we'll take it from there. So with that being said, thanks for watching. Please give me a like and a sub. And stay tuned for more. See you all later.